a table. It has 3 columns. You have cation, few drops of ammonia solution, and excess ammonia solution. So we have zinc. If you have a test tube containing zinc ions in solution and you add a few drops of ammonia solution, you get a white precipitate, and in excess of ammonia solution, you get a soluble, or the precipitate dissolves. When it comes to aluminium, lead, and magnesium, independently, because we are saying this is done separately, a test tube with aluminium ions, a test tube with lead ions, a test tube with magnesium ions, you get a white precipitate in few drops of ammonia solution, and the white precipitate is insoluble in ammonia solution. If you have a test tube that contains calcium ions, a few centimeters cubed, you add a few drops of ammonia solution, you get no white precipitate. That is the language we use. And in excess of ammonia, we also get no white precipitate. That means when that happens, then you can conclude that the solution in there contains calcium ions. For iron 2 ions, that is iron 2 ions, Fe, 2 positive ions, and you add a few drops of ammonia solution, you get a pale green precipitate, which is insoluble in excess of ammonia solution. For iron 3 ions, if you put them in a test tube and add a few drops of ammonia solution, you get a brown precipitate, which is also insoluble in excess. If you have copper 2 ions in solution, or a salt that is dissolved and it contains copper 2 ions, you add a few drops of ammonia solution, you get a blue precipitate, and in excess of ammonia, you get a deep, or it dissolves to form a deep blue solution. So blue precipitate, but in excess of ammonia, it dissolves to form a deep blue solution. So that is about sodium hydroxide and ammonium hydroxide being used to test for common ions. And you will notice that some of them will actually help us identify the specific salts.